Okay, so for the sets here, we want to give an inductive definition for each of them. And an inductive definition for set S, it needs to have two elements. So the first element, we need to state the first element of S, first element of S. So that's the first part. And the second is if little s belongs to capital S, so if an element belongs to it, state its successor. Okay, so it's basically this idea of how do you get from one element to the next one within the set, right? So for the inductive definition, you just have to fulfill these two criteria. So for set A, now let's just expand this just to see what it looks like. So this set here is going to be the set containing the multiples of the natural numbers, multiple of 5, right? So it's going to have 5 times 1, 5, 5 times 2, 10, 15, 20, and so on. So we need to fulfill the two criteria. So for the first item, we're going to define S as follows. We're going to say that 5 belongs to S, right? And for the second item, we're going to say, okay, if S belongs to S, so if we're going to say if N belongs to S, because S is going to have natural numbers, right? How do we get to its successor? Well, its successor is always going to be n plus 5, because think about it, 5 plus 5 is 10, 10 plus 5, 15, plus 5 is 20, and so on. So if n belongs to S, it means that n plus 5 belongs to S as well. So we've fulfilled the criteria, right, for an inductive definition, and that is it. So that's item A. What about item B? Item B, we're going to have that all the natural numbers beginning from 11, because it has to be greater than 10. So we're going to have 11, 12, 13, 14, and so on. So for the first item, we have to state the first element of the set. So we're going to say that 11 belongs to the set. And for the second item, we're going to say if n belongs to the set, right, then n plus 1 belongs to the set. Because then we're going to go 11, 12, 13, 14, 15, and so on. So that's item B. Now, what about item C? So let's expand item C just so that we see what it looks like. So you're going to have 2 to the power of k for the natural numbers. So you're going to have 2 to the power of 1 is 2. We're going to have 2 to the power of 2, 4. You're going to have 2 to the power of 3, 8, 16, and so on and so forth. So first state the first element. So we're going to say let 2 belong to the set. And we're going to say how to get, if a number belongs to the set, so if n belongs to the set, how do we get to its successor? Well, we just say then 2n belongs to the set, right? Because if 2 belongs to the set, then 2 times 2 belongs to the set 4. So 2 times 4 will be the next one, 2 times 8 will be the next one, and so on. So that fulfills the criteria. Let's do item D, where we're going to have A plus D, A plus 2D, and so on and so forth, right? So we're going to say, for item 1, we have to show the first element. So we're going to say let A belong to the set, where A is a real number, right? And so that's the first thing, because we have mentioned how to get to what the first element is, right? And now we have to show how to get to the next one. So if maybe we can say if n belongs to S, then n plus D belongs to S, and then maybe 4D belongs to the real numbers. So it's this idea that, hey, if A belongs to S, then A plus D will belong, right? And then A plus D, which will be A plus 2D. And then A plus D plus D plus D will be A plus 3D, and so on. So it tells us that, hey, from any element to the next one, I just have to add D to it. So we fulfilled the criteria for the inductive definition because we've shown how to get from one element to the next. So we did item D. Now let's do item E. So similarly, we're going to state what the first element is. So we're going to say let A belong to S, where A is a real number, right? For A is a real number. And then for item 2, how do we get to the next element? We're going to say if N belongs to S. So let's see. You can see that from one element to the next, we're just multiplying by R, right? From AR to AR squared, you just multiply by R. From this one, from this here to that one, you just multiply by R. So we say if N belongs to S, then NR, oops, that's going to be little r, then NR belongs to S. And then maybe we say where R belongs to the set of real numbers. So that is it. We have described how to go from one element to the next. We just, between each of them, you're going to just have a multiplication by R. So now let's do item F. So item F, we're saying the union, right? How to describe the union from 1 to n. So F, we're just going to say what the first element is. So we're just going to say, okay, let the union, so let the union from I is equal to 1 to all the way out to 1. So the union of the first one of AI, define it to be just A1. Because we're saying, hey, maybe the union of from 1 to 5 is going to be A1 union, A2 union, A3, A4, and A5, and so on. So we've defined what the first union is. And now we have to define how to go from one union to its successor. So we're saying the union from I is equal to 1 all the way out to n plus 1 is going to be defined as the union of n with the next element of A sub n union with the next one. So from this, we can clearly see that we know what the first union is going to be. The first union is just A1, and then it tells us how to get the union from 1 to n plus 1 out of the union of n with its next term. So we can clearly see here that there's a very clear notion of the successor, even though it's not, the successor is not a term per se, but it is a union. And now let's do item G, which is the same thing, but now this is the product, right? So let's just say what the first one is, the first item. So we're going to say that item I, the first product from I is equal to 1 all the way out to 1. Well, that's just going to be x1, right? Because we want to multiply x1 times x2 times x3 and so forth until xn. And now we're just going to describe how to go from one term to the next one, from one product to the next one. So we're going to define that the product from I is equal to 1 all the way out to n plus 1. So this product here is going to be defined as, it's going to be defined as the product from I is equal to 1 to n multiplied by x n plus 1. So it's this idea that, hey, to get to xn, you can just go the product from x1, x2, x3, and so on until xn minus 1, and then multiply that by xn, right? It's this idea of the factorial. So that is it for problem number 5. We've defined all of these inductively, and once more, to define it inductively, it just means 1, to state the first element of the set, and 2, to state how you get from one element to its successor. And that is it.